One of the things that we have to talk about is we're going to discover first the pattern for a 30, 60, 90. So if you notice, we are still dealing with the right triangle. There's a 90-degree angle, but this is a very special situation where one of the angles is 30, the other one is 60. So again, we're going to try to discover the pattern. Math is all about patterns anyways. So it says, examine the triangles below carefully. Do you notice a pattern? Well, this one has a 2 underneath, right? And this is the smallest side. The other leg is 2 radical 3, so it also has that 2, but with a radical 3 next to it. And then my hypotenuse is 4. Again, we're just looking at it. Right here, the shortest side is 3. The other leg is, there's that same 3 again, but with a radical 3. And then they have a 6 for the hypotenuse there. And finally, this one has a 4. Well, there's that same 4 for the other leg, but with a radical 3. And then they get an 8 for it. So if we see a pattern, this is my short leg right here. It's the shortest side. Then what would I call this long leg based on the pattern? Anybody? Let's go. Yeah, 10 radical 3. Look, the pattern is saying if this is a 3, that's 3 radical 3. If that's a 4, that's 4 radical 3. Well, if that's a 10, then that's a radical 3. So if you think about it, all I'm doing is I'm taking the short leg and I'm going to multiply it by radical 3. I'm going to put a radical 3 next to it. All right, but now we got to try to find a pattern for the hypotenuse. This was a 2 and then this was a 4. This was a 3 and then it was a 6. This was a 4 and then it was an 8. So if this is a 10, what would I write here? 20. Perfect. So what's the pattern? What do I do to the short leg to get the hypotenuse? Yeah, just multiply it by 2. And that's it right there. That is the pattern for 30, 60, 90. 4 times 2, there's 8. 3 times 2, 6. 2 times 2, there's my 4. This only works for 30, 60, 90. But it can help you find missing sides very quickly. In fact, look at the short leg right here. If this is a 1, then what's this side going to be? 1 radical 3, and I don't even have to write the 1 because they tend to be invisible next to a radical. You can write it, same thing. And then what would be my hypotenuse? A 2. The idea is that if you know your short leg, it helps you find the long leg, and then the hypotenuse, we multiply by 2 based on these rules. But this only works very specific for a 30, 60, 90. Now, if you notice, one of the first things I locate is the short side, the shortest side of the triangle. So when I'm looking at my first example, it says use the original 30, 60, 90 triangle to find the missing sides below. For each one, state the scale factor. All right, so here's what they mean by that. This right here is the shortest side. Well, if that's the shortest side, they gave me the hypotenuse. Well, remember what the rule is. What do you do to the short side to get the hypotenuse? Multiply it by 2. So then if I have the hypotenuse, how do I find the short side? Divided by 2. So 14 divided by 2 is 7. Well, there you go. We already found what B is. It's just the 7. They gave me the hypotenuse. Well, then I have to use the rule backwards. And all I'm going to do is divide by 2. And now that I know the short leg, well, how do I use that to help me find the long leg? Multiply by radical 3. So my answer is 7 radical 3. And there's my answer for A. So we can put it right in the picture. If it's too small, look, B is 7 and A is 7 radical 3. So what is the scale factor? What is it that they all have in common? The 7. Your short side is your scale factor. They all have that 7 in common. But again, one of the first things you have to do is recognize where's the short leg, because the formulas come off of that. And if you haven't noticed it, if this is the 30 right here, well, that's why that's the smallest angle. That is the short leg right there. So here we have a 60 for the second one. Well, then that means this is the 30. And if that's the 30, I always like to locate the short leg This is the short leg right here. But what side was given to me? Yeah, the hypotenuse was given to me this time. So if the hypotenuse is given to me, they said the hypotenuse is 12. All right, well, let me use my formula backwards. What am I going to do to that 12 to get my y value? Divided by 2. 12 divided by 2 is 6. So there you go. We just found that y is 6. And how do I find the long leg? Multiply by radical 3. So 6 with the radical 3 right next to it. Again, the scale factor here is they all have a 6 in common. They're all dealing with the number 6. That's what they mean by the scale factor. Okay? All right, then there's number 3. Now, number 3 doesn't have every side, but they do tell you up here that z is equal to 4 radical 3. Well, then, let me go put that in now. Might as well. This is 4 radical 3. All right, well, think about it. This is the hypotenuse. I'm not going to divide that by 2. That's not what I'm supposed to do there. This is the long leg. This is the short leg right here. So if this is 4 radical 3, all right, well then, what's your y value going to be? Yeah, the 4. Remember, the short leg and the long leg always use the exact same number twice. There's no difference there. So that's a 4. But now, how do I use this 4 to find the hypotenuse? So then what's 4 times 2? And there you go. 8. And just like that, we're done. So much faster than trigonometry. We can't even use Pythagorean anyways on it. Technically, we could use SOHCAHTOA, right? Trigonometry. But when it's a 30-60, we don't waste our time. They always follow the same pattern. So if you memorize the pattern, it is a little bit easier to work on with these problems. Okay? Now, that was the 30-60. So there's another very special set of triangles, also from your geometry days, and that is the 45-45-90. So you see it's still a right triangle. There is that 90 involved. But when it says 45-45, that means two of your angles are exactly the same. And so here we see the 45 and the 45, all the same there, the same. All right, well, what do you notice about the legs? All right, the orange are the legs. What do you notice about the legs? They're the same. Back in geometry, we used to do this. We used to put little lines to say, oh, they're equal, they're congruent. Well, look, the legs are 3 and 3. So 3, 3, 4, 4. So if that's the case, if this leg is 7, then what am I writing here? 7. Because the rule is, for this one right here, the legs are equal. Or you could write the same, whatever's going to help you figure that out. But in a 45-45, these two legs should be equal to each other. So that's why if this one over here is a 1, well then what's this one going to be? A 1. Right? The legs need to be the same. Look, we just found missing sides. We didn't really do much work. But now let's talk about the hypotenuse. When I'm looking at my hypotenuse, this is a 2, this is a 2. Well, there's the 2, but it's got a radical 2 next to it. This is a 3, this is a 3. Well, there's the 3 again, but it's got a radical 2 next to it. 4, 4, there's the 4, but it's got a radical 2 next to it. So if this is 7 and this is 7, then what's my height going to be? 7 radical 2. Because the rule is you're going to take one of the legs, and to get this, all you're going to do is multiply by radical 2. Now we say multiply because you're writing it right next to it, and that's what you do with multiplication. You're really just writing it where it belongs. And so what side is this? What's the height on this one? Yeah, radical 2. That's it. Again, they follow patterns, but these are the only two that do. It's got to be a 45-45-90 or a 30-60-90. And of course, they're all in your word wall. They're all there in case you need it. So, for example number 6, it says, all right, use the original 45-45-90 to find missing sides below. For each one, state the scale factor. Well, look, the scale factor for this one, 2. The scale factor for this one, 3, because they all have a 3. 4, 7, 1. Scale factor just means what's that one number they all have in common? Well, it's the 2 for this one. All right, so look how quickly this goes. There's a 90. There's a 45. But just so you know, if this is a 90 and a 45, well, then by force, this is a 45 as well, which means if this is 12, then what side is this? 12. And if these two are 12s, then what's your x going to equal? 12 radical 2. See, you're already done. You should be happy when you get these questions because there's not a lot of work. You just have to remember the rule. And you have a word wall that helps you. All right, look at this one. The z is 9 radical 2. Well, if this is a 45 and that's a 90, well, this is 45. And remember, if they're both 45s, we know these sides are equal. So if this is 9 radical 2, then how much is y? 9. How much is your x? 9 as well. See, already done. They're the quickest ones to solve. That's why we save it till the end. That's a 9. All right, and then finally on this one. Oh, did they say this is 45? No. But if you think about it, remember, what did we say all 3 angles of a triangle add up to? 90, right? So if I were to take a calculator, which is now missing, there it is. So look, if they didn't give me the angles, but they said, hey, this is 90, right? 180 minus 90 is 90. These angles are exactly the same, they said. Well, then I'm going to go 90 divided by 2, and there's your 45. So they are 45s, even if they didn't write them, because when they tell you the angles are the same, well, it can only be 45 for both. So with that said, you should be done. What is the value of n? 15. There it is. Questions on these 2 rules? Okay, flip it over. Flip it over. I know it says you try, but I want to show you something first. And then we'll do the you tries. Or actually, you know what? Let's just do this here really quick. All right. Just to continue the practice, but I'm calling you, so just be ready. Okay? All right. If the measurement of angle D is 60, okay, so this is 60. And then that one's 90. All right, well, then by force, what's this angle going to be? 30. They said find the lengths of DE, so they want you to find this side, and they want you to find EF. They want you to find this side right here. All right, let me get it ready. DE equals, EF equals. All right, well, what side did they give you? What side did they give us? What side is this? Yes, EF, but it's the hypotenuse, right? Right triangle. It's a hypotenuse. So then, Giancarlo, if they told me that this is 22, how do I find the short leg? All right, and what's my answer going to be? And so there you go. We now know DE is 11, so let me get that 11 going. But now that we know that, well then, Crystal, if I know this side is 11, then how much is the longer leg going to be? 3, yeah. And so that's the only thing that people tend to forget. It's like, man, is it the radical 3 or the radical 2? Remember, there's a 30 in it. I always remember there's a 3 then involved. But then that's it. So we're done. We use the rule. We don't have to use trigonometry. Definitely Pythagorean was out, so we knew that wasn't going to work. All right, great. Now, look at number 4. Angle G is equal to angle I. Okay, so mark it. But in a right triangle, we said if you have 2 angles that are the same, well, then they're both 45s. So if that's the case, they tell you GH is 10. Well, let's write it in. There's the 10. And then they said, find me HI and find me GI. They want me to find these 2 measurements. Well, let me get my answer ready here. HI, GI. All right, so then phi. If this side is 10, then how much is HI? 10, because they're supposed to be equal to each other. And then phi, what is my hypotenuse going to be? Yeah, and square root of 2. And just like that, not much work needed. You just have to remember the rule. This is a 45-45. These two are equal, same number, same scale factor, but with a radical 2 every time. All right, and finally, they said this side is 14. They said BC is 14. Radical 2, well, think about it. There's only one triangle where this can happen. If this is 14 and this is 14 radical 2, then what's this side? But what did they ask us for? They want the measurement of angle C. Well, what kind of triangle is this then so that this rule does apply? Yeah, it's got to be a 45. And just like that, we're done with that question. The measurement of angle C has to be that 45-degree angle. And again, I didn't use inverse trig. I mean, maybe I could have, but I didn't have to. We could just solve it from there, just by knowing the rule. All right, so this gets us ready for our very last example of the day. Perfect timing here, because I know some of you are done with everything. So, last idea of the day. How do we use this to help us with trigonometry? So we're going to do the same thing we just did. Okay? There's my 30, there's my 60. So we know this is a 30-60. This is the shortest side right there. Well, they already gave me the height. My h is 10. So you're supposed to go straight to your short side right away. Then, Derek, if my hypotenuse is 10, what do I do to that 10 to find the short side? And what's 10 divided by 2? So there we go. We have this side 5. All right. And then still your question, Derek. If this is a 5, then how much is this side right here? Square root of 3. There you go. Perfect. All right. Well, look. We have everything we need. Now we're going to bring in what we learned the other day, which is, all right, well, we got a little trigonometry going. It says sine, so I know it's O and H, according to our SOHCAHTOA word here. All right, but they said angle D. So I'm going to mark this angle D here. This is already the H, so that makes this the opposite. That makes this the adjacent. All right, opposite is 5. Opposite is 5. Hypotenuse is 10. Well, what is 5 over 10? Because you always reduce your fractions. 1 over 2. There's my answer. All right, we're just doing what we did the other day. We're just combining two ideas now. All right, well, now it says cosine. Well, cosine, according to SOHCAHTOA, is A and H. Now, can I still use the same HOA? Yeah, it's the same angle. Look, it says D. So I'll still use it. All right, well, A is 5 radical 3. H is 10. All right, now I know it has a radical. You still need to reduce it. The 5 and the 10 earlier reduced to 1/2. Well, there's a radical 3 on top. Well, then just leave the radical 3 on top, and your 10 goes at the bottom. And then there's my answer. Well, not a 10. What is it? A 2. Sorry, 2. You reduced the 5 over 10 earlier. Well, I'm still reducing it. I just have to leave the radical where it belongs. Now, these last two are using F as my angle. And if they're using F as the angle, am I still keeping this as my H? Yes, no? Oh, yeah, of course. That's never going to change. But is this still going to be the O? No. For the letter F, this is now A, this is now O, and now I'm ready to just do what we did before. So cosine is AH, which means my A is 5, my H is 10, and we reduced this one earlier, so it's just 1/2. There it is. And then this one is F also. TOA, according to SOHCAHTOA here. O is 5 radical 3. A is 5. All right, so tell me, what does that reduce to? Yeah, just radical 3. Remember, radical 3. The 5s are gone. They're just going to cancel each other out, but you still have that radical 3 going. Questions on that? All right? And finally, find each trig ratio. Again, look, there's all these fractions, but this time it's a 45 with a 45. So if this side is radical 2, and I think I called on everybody. Yeah. Yeah. What are these sides going to be? 1 and 1. Perfect. That's it. And now I understand, like they said, hey, you're going to work with letter D first, but that's a 45. Don't forget, E later on is also a 45. So no matter what, we're still going to be able to use the same angle. So right now we're going to do it for the letter D. This is the height, of course. That's never changing. This is the opposite for this angle right here. And this is the adjacent. All right, sine is OH. All right, so O is 1. H is radical 2. And can I do anything there? No, that's it. I'm done. There's my answer. Sometimes you can't reduce. All right, well, this is also the letter D, so I don't need to change anything. Tangent is O, and then A, according to SOHCAHTOA. The O is 1. The A is 1. Well, I'm not going to leave it like that. What do I just write as an answer? Yeah, just 1. 1 over 1 is just 1. That's it. All right, but now they changed the angle on me. So because they changed the angle, now it's this one right here at the bottom, E. Can I still use that H? Yeah. Is it still my adjacent? No. Now it's the O. Now I change that to an A, and now I'm ready. Cosine is AH, which means 1 over radical 2, and we already said you can't do much with it. That's pretty much it. And then sine, as we mentioned before, is opposite over hypotenuse, which is 1 over radical 2. And so notice the 45-45 uses a lot of the same numbers over and over and over. Even this one over here when we reduced it. Okay?